the parameters of motion. Means when the body is in motion, then what are the parameters are involved during its motion. Means displacement, distance, velocity, speed, acceleration, retardation, like that. So in also we did that, we learnt about that what is uniform motion. Uniform motion means when the body is traveled in equal distances in equal intervals of time. Means when a body is moving, first second when the body traveled, time taken by the travel to the 30 minutes, then at the first minute body traveled for 10 meters, then the second minute also it has to take in there the another 10 minutes only, 10 meters only. So here is that when the body is traveled equal distances in equal intervals of time is called as a uniform motion. And also uniform velocity. Uniform velocity means the body is traveled equal displacements in equal intervals of time is called as a uniform velocity. Like that, here the uniform acceleration is also we'll learn about it. What is meant by the uniform acceleration? Uniform acceleration means body is already in the motion, which is having that small velocity. It's having that initial velocity, all some of the velocities it have. So the body is increases its velocity equally in equal intervals of time. Its velocity goes on increasing. Means at the first second if it is increased by the 10 meter per second, and another second also it has to increase at the 10 meter per second only. Means it is increment, not maintaining the same velocity. Means if in case of the, if it is maintaining same velocity, that will be uniform velocity, then acceleration will be 0. If the body is in uniform velocity, then acceleration will be 0. So that here uniform acceleration means that body must be increasing its velocity in equal intervals of time is called a uniform acceleration. By using this, when the kinematical equations, what are the kinematical equations? Means when the body is traveling, to find out the velocity or acceleration or time, displacement. Earlier we have discussed about the parameters. To know the values of parameters, somehow here the four equations of kinematical equations of motion is there. Those are, let's see what are they. So first one is V is equal to U plus AT. This is the kinematical equation. Kinematical equation means this is the relation between the velocity time relation. It is also called as velocity time relation. It is also called as a velocity time relation. Velocity time relation. This one is the velocity time relation, because of it is between the velocity and time relation. The next one is second one is S is equal to UT plus half AT square. UT plus half AT square means here is the S means displacement. This is the relation is also called as a displacement time. Displacement time relation. Displacement time relation. It is also called as a displacement time relation. Here the next one is third relation will be V square minus U square is equal to 2AS. This relation is also called as velocity displacement relation. Velocity displacement relation. Velocity displacement relation. By using this velocity we can find out that retardation and acceleration, as well as to find out, we can find out the displacement, we can find out the values, initial value, initial velocity, or final velocity, like that. So the last one, the next one is fourth equation is nth second. That means the displacement of a particle at some of the nth second. The instantaneous displacement, if taken that when the nth second or nth time, then Sn is equal to U plus A of n minus 1 by 2. Or this is also can be written as or this relation is also can be written as Sn is equal to U plus A by 2 into n minus 1. These are the kinematical equations of motion. And also another relation is also there that is useful for the stopping distance. Stopping distance means here we can see that stopping distance means the relation between the time and the displacement. That is S is equal to v plus u by 2 into t. V plus u by 2 into t. This is the relation for the stopping distance, means the relation between the displacement and time, as well as we can find out that acceleration is also. So by using this relation we can find out, we can do the problems. Then these are the relations are called kinematical equations of motion. So let's see how prove it. Let's see the kinematical equations. We will verify that one and we do the proof. The first one is a velocity time relation. Velocity time relation. The velocity time relation will be, the first one is a velocity time relation. That is a v is equal to u plus at. V is equal to u plus at. This is the velocity time relation, we can say that. Then by using the graphical treatment, this is the graphical method. Let's see, listen carefully. The values which can be taken, time is the taken in a x-axis, along x-axis the time, and velocity along a y-axis. This is a y-axis and it is a x-axis. So here I already mentioned that is uniform acceleration. Uniform acceleration. What is meant by the uniform acceleration? That consider a particle is already having some of the velocity, initial velocity u, means this is u. A particle is having a initial velocity u. After traveling some distance in time t, consider, first of all, consider a body of its initial velocity u, and traveled in a time t. In time t means some of the travel, it is traveled some of the time t. According to this is a t. Here is that. Its a final velocity. Its a final velocity will be v. Means whenever it reaches this one, then the total velocity will be v. The final velocity will be v. So here is a, consider it's a b. I am drawing a imaginary line which is perpendicular to the BCD. A body having that initial velocity u with uniform acceleration, body will ever traveling in uniform acceleration. Uniform acceleration means that body is already have some of the velocity u, its initial velocity, and traveled with the time. Uniform acceleration means with the uniform time the body is also traveled, the velocity is also increasing with the time. Velocity is increasing with the time. So that's why the time is increasing. After time t seconds, its initial final velocity will be v. So here is that, this is the u and the total will be v because of velocity time graph. We are taking here that the velocity time graph. So that's why here the total can be considered as a, this is considered as a v. So from that we know that this is a u because of which is parallel to this one. So that's why this will be u, and finally this will become v minus u. V minus u because of the total will be v and velocity v, and whenever this value will be u, then we can take that this value becomes a v minus u in time or t. This is also parallel to this one. So that's why this value will be u, and which is making an angle theta with the horizontal x-axis, with the horizontal line which is parallel to the x-axis. So this is the graph which is useful to determine the all the kinematical equations of motion. So concentrate on one another. Whenever the body is moving with uniform acceleration, means already body is having some velocity, and with that time the velocity is increasing, so it reaches to b, then in time t. The body reaches to b in time t. So that's why we are drawing the imaginary line perpendicular to this a b d. The means the total body displacement which is under the AB curve, AB line under with the x-axis will be the total displacement will becomes this one, A, B, C, D, O, A. That will be the total displacement of the body. Then here let's see what is velocity time relation. We can find out that from the slope, means from the slope AB, from slope AB we can write that from the triangle ABC, from the triangle ABC, from the triangle we can write that it is tangential to the, it is tangentially move curve, tangential line. So that's why we can take that tan theta which is equal to, tan theta is equal to, we know that tan theta is equal to opposite by adjacent. Then what is opposite? BC, BC by what is adjacent? AC. So AC, but we know that what is BC? V minus U, V minus U, and what is AC? Means T, which is, we know that the tan theta is, the angle will be the very small which can be written. So when we know that V minus U by T is equal to, this is the definition of acceleration, means the rate of change of velocity, means the velocity changes with the time, the change in velocity with the time. So that's why we can write that V minus U by T is equal to A. V minus U by T is equal to A. From this relation we can write that V minus U is equal to AT. V minus U is equal to AT. From that V is equal to, whenever the U taken to this side, then it will becomes minus U becomes plus U. V is equal to U plus AT. This is the relation between velocity and time relation. This is velocity and time relation, which can be kinematical equations of first kinematical equations of motion. Once again, let's see. Whenever the body is moving with uniform acceleration, means it is already having some initial velocity, that is a U. Whenever it travelled after t seconds or t time, then its final velocity becomes V, means the final velocity will be V. So that's why we are taking that, we are drawing an imaginary line to the perpendicular x-axis and y-axis to know the position, and from the point of A, then the distance travelled by this is the total value, then we can get, then the final velocity minus initial velocity, the distances we have taken by using the graphical method. From the relation we can write that is tangential, so that's why we are taking tan theta, that is equal to BC by AC. Then from that V minus U by T is equal to, we know that is acceleration, means the rate of change of velocity is called as acceleration. So from that acceleration we can take that whenever taken to the T this side, then it will multiply with the A. So V minus U is equal to AT, then V is equal to minus U taken to this side, then it will becomes minus U becomes plus U. So V is equal to U plus AT. This is the equation for first kinematical equation. So next, the second kinematical equation will be the second one. The second one is a displacement time relation. Displacement time relation, that is S is equal to ut plus half at square. This is the most important relation in public examination. We get the, mostly we can get per 4 marks. This is the most important relation in the public examination. He asked for x is equal to ut plus half gt square, ut plus half gt square or half at square also, because of, in case of acceleration due to gravity, it will not act. Whenever the body is moving vertically, then only acceleration due to gravity is act on the body. Whenever the body is moving horizontally, then the body will be traveled acceleration. So that's why we can take that at square or gt square, both will be same whenever the body is moving horizontally, because of at every point the body acceleration due to gravity is acting same on the body. So here it is that we can ask, they can ask like this also, instead of u he can ask v naught t also. X is equal to v naught t. V naught t means v naught means here the velocity at a 0 time. X is equal to v naught t plus half at square. x is equal to v naught t plus half a t square, or s is equal to ut plus half a t square also you can ask for 4 marks. The very important question for the academy intermediate public examination. So first of all, by taking this, to know that this is the time displacement time relation. So when the body is traveled after t seconds, the body reached to the point B, then the total relation, the total displacement of a body, this is under the AB line, under the AB tangent line, which is drawn perpendicular to the x-axis. Under the, from the x-axis line, this will be the total displacement, that is S. Means the S be the displacement, total displacement. S be the total displacement. S be the total displacement. We can say that we can divide this to, for our easy convenience calculation. For easy calculation, we can divide this. We can draw the perpendicular. We already have. Here is one triangle is there, and another rectangle is there. So if we add the area of triangle and area of rectangle, then we can get the total displacement. The total displacement we can get. So that's why S is the total displacement. We have taken that. That is S is equal to area of triangle plus area of rectangle. Area of rectangle. So area of triangle plus area of rectangle. We know the formula, mathematical formula of area of triangle and area of rectangle. What is area of triangle? Area of triangle means half into length into breadth. So that's why S is equal to, triangle means here ABC. Triangle ABC. Here rectangle means OACD. OACD. So for the easy calculation, S is equal to, triangle means, area of triangle means half into length. What is the length? This will be the AC into breadth means V minus U. V minus means here the AC, right? AC into BC plus the area of rectangle, length into breadth means OD into CD. OD into CD. So already total values we have, so that's why we are substituting the values. Then first of all I am writing OD into CD, that is OD means the time T into CD means the value will be U into U plus next half AC means T into BC means V minus U. So S is equal to UT plus half. V minus U means we know that from the relation here, V minus U is equal to AT from the kinematical equation. Since here we are writing the T into AT. Since V minus U is equal to AT. Because of V minus U is equal to AT, we are writing that half T into AT. So from the relation we can write that S is equal to UT plus half AT into T, AT square, half AT square. This is the second equation for the kinematical equation. This is the first one, and this is the second equation for kinematical equations. Once again, to know the displacement when the body is traveled with uniform acceleration, which is having that initial velocity u, after t time, then the final velocity will be v, then the curved line will be that it is tangential line. So that's why AB, under the AB area will be the total displacement of the body. So here it is that when the AB taken the perpendicular drawn on the x-axis, then here the total area means here one rectangle is there, one triangle is there. So that's why the area of rectangle and area of triangle we can, if we sum the both, then we can get the total displacement. From the displacement, area of triangle or area of rectangle, which can be add like anything. So S is equal to 1 by 2 into area of triangle is half into length into breadth. So that way height into breadth. So that's why length into height. Then half into AC and half into BC plus OD into CD means here the length into breadth. The length into breadth is CD into OD. OD into CD. From that also we can write that T into U plus of T into V minus U. We are by substituting these values in the equation, then we can get that S is equal to UT plus of T into, we know that V minus U is equal to AT from the relation, from the initial relation V minus U is equal to AT. By substituting that value we can get that S is equal to UT plus of AT square. This is the relation for displacement time relation, the second equation for the kinematical equation. So this is the very important formula to find out the problems by the time, to find the time and also to find the displacement. And according to the intermediate public examination, this is the very important from this motion in a straight line lesson to give, mostly we can get this problem like x is equal to v naught t plus half a t square, like that. If in case of the displacement is overall that this is the displacement which happened, so that's why we can say that here according to the x axis, so that's why displacement s is equal to, you can write that x. Then also initial velocity, we know that u is equal to velocity at time 0, that is v naught. By substituting these values we can write that when s is equal to x, then s is equal to x and u is equal to v naught, then also we can write that x is equal to v naught t plus half a t square, also we can write that. This is also equation for displacement time relation. This is about the first and second kinematical equations of motion. Let's see the third kinematical equations of motion.